Hi students, myself Kale SL, Rayat Shikshan Samsthas, RBNB College Rampur, Class 12th Science, Mathematics Part 2, Lecture number 6, Topic Definite Integration, Exercise 4.2. In the previous video lecture, we have completed properties of definite integral. 7 properties we have completed and we have to see 8th property. Before to see 8th property, we revise first 7 properties like this. Integration from a to a f of x dx, if upper limit and lower limit is same, then it is equal to 0. Second property here, integration of a to b f of x dx, if we want to change upper limit and lower limit, then it is equal to minus integration from b to a f of x dx. And here third property, integration from a to b f of x dx is equal to integration from a to b f of t dt. That means definite integral does not depend upon the variable, it depends on lower limit and upper limit and the function. And the fourth property, if a is less than c is less than b, a is less than c is less than b, then integration from a to b f of x dx is equal to integration from a to c f of x dx plus integration from c to b f of x dx. Now fifth property here, integration from a to b f of x dx, that is equal to integration from a to b, and replace this x by, we replace this x by a plus b minus x, f of a plus b minus x dx. This is the fifth property. Sixth property we have seen, integration from 0 to a f of x dx is equal to integration from 0 to a, we replace x by a minus x, so it is f of a minus x dx. And here seventh property, integration from 0 to 2a f of x dx, it is equal to integration from 0 to a plus integration from 0 to a. In first part here it is f of x dx, and in second part we replace x by 2a minus x, f of 2a minus x dx. So these are the 7 property which we have proved in the last video lecture. Now we see here 8th property. 8th property here, integration from minus a to a f of x dx, it is equal to 2 times 0 to a f of x dx if f of x is an even function, and it is equal to 0 if f of x is an odd function. Now proof of this, if f of x is an even function, here f of x is even function, f of x is even function, then f of x is equal to f of minus x is equal to f of x, f of minus x is equal to f of x, and f of x is odd function, f of x is odd function, then f of minus x is equal to minus f of x. These are the definitions of even function and odd function. If f of minus x is equal to f of x, then the function is even, and if f of minus x is equal to minus f of x, then the function is odd function. Now here we consider, let integration from minus a to a f of x dx, we write this as integration from minus a to 0 f of x dx plus integration from 0 to a f of x dx using the fourth property. Here fourth property is a is less than c is less than b, then integration from a to b f of x dx is equal to integration from a to c f of x dx plus integration from c to b f of x dx. Using this property, we write here integration from minus a to a f of x dx is equal to integration from minus a to 0 f of x dx plus integration 0 to a f of x dx. We call this as equation number first, because here this 0 lies between minus a to a, and so we write this. Now here consider this. Consider integration from minus a to 0 f of x dx. Put here x is equal to minus t. We put x is equal to minus t and differentiate with respect to x. Derivative of x is 1. It is equal to minus dt upon dx. Carry that dx, so 1 into dx, that is equal to dx is equal to minus dt. Now we change here lower limit and upper limit. These are the limits of x. Now we find the limits of t. So when x is equal to lower limit minus a, x is lower limit minus a, then t is equal to this. We put here x as minus a is equal to minus t, minus sign get cancelled, so t is equal to a. And when x is equal to upper limit here 0, x is equal to 0. Now put here x is equal to 0, so we get minus t is equal to 0, that is t is equal to 0. So here limit change minus a0 to a0, and therefore this integral becomes minus a to 0, integration from minus a to 0 f of x dx. We write this as integration from, now minus a to 0 change to a to 0, so we write lower limit a, upper limit 0. F of, we replace here x, we replace x by minus t, so this is minus t, and dx, replace dx by minus dt, so here it is minus dt. So it is equal to, now take this minus sign outside the integral, minus integration from a to 0 f of minus t dt. And now here, due to this minus sign, we change this lower limit and upper limit using the property number here. Second, integration from a to b f of x dx is equal to minus integration from b to a f of x dx. And so we write this as 0 to a f of minus t dt, because here we use property integration from a to b f of x dx is equal to, it is equal to minus integration from b to a f of x dx. And so it is equal to, now here we change the variable, instead of t we write x, we have the property, so integration from 0 to a f of minus x dx. And for this we use here third property, that is integration from a to b f of x dx is equal to integration from a to b f of t dt. And so we get here integration from minus a to 0 f of x dx as integration 0 to a f of minus x dx. And from equation 1 we write now from 1 integration from minus a to a f of x dx, and here minus a to 0 f of x dx we replace by 0 to a, that is 0 to a f of minus x dx plus 0 to a f of x dx. Now take here integration from 0 to a common, and we get f of minus x plus f of x. Get it? Now if f of x is even function, if f of x is even function, and so it is equal to integration from 0 to a, we replace this f of minus x by f of x, because f of x is even function, and we know that if f of x is even function we get f of minus x is equal to f of x. So replace this f of minus x by f of x and plus this f of x as it is, and here dx, here also write dx. And now this f of x plus f of x, it is equal to 0 to a 2 times f of x dx. Now this 2 take outside the integral, so 2 into integration 0 to a f of x dx. In this way we get integration from minus a to a f of x dx is equal to 2 times 0 to a f of x dx if f of x is an even function. Now if f of x is odd function, if f of x is odd function, then this step becomes, so this is equal to integration from minus a to a f of x dx, it is equal to integration from 0 to a, and we replace this f of minus x by minus f of x, because f of x is an odd function, so f of minus x is equal to minus f of x. So 0 to a, this f of minus x we write minus f of x and plus this f of x and dx, and now this f minus f of x and plus f of x get cancelled, so here it is integration 0 to a and here 0 dx, it is equal to 0 into integration 0 to a 1 dx, that is equal to 0. So when f of x is an odd function, we get integration from minus a to a f of x dx is equal to 0. So this is the proof of this theorem. Take the screenshot, learn this property, very important property. So in this way we have completed totally 8 property of definite integration. Now here we see exercise 4.2 question number 3rd. We have completed question first and question second. Now we start here question number 3rd. Question 3rd, evaluate. Problem first is integration 0 to a 1 upon x plus under root of a square minus x square dx. Integration 0 to a 1 upon x plus under root of a square minus x square dx. Now if we remember, when there is under root of a square minus x square, we use the substitution. When there is under root of a square minus x square, we use substitution. Under root of a square plus x square, also we use the substitution. Under root of x square minus a square. So when under root of a square minus x square, we put x is equal to a sin theta. Here we put x is equal to a tan theta, and here we put x is equal to a sec theta. These are the substitutions. Now in given problem, in the denominator there is root of a square minus x square. So put here, firstly call this problem as I is equal to integration 0 to a 1 upon ax plus under root of a square minus x square dx. So put here x is equal to a sin theta. This implies sin theta is equal to x upon a, and theta is equal to sin inverse of x upon a. From this equation we write sin theta is equal to carry this a, x upon a, then carry sin, so sin inverse of x upon a. Now differentiate this equation with respect to x. Derivative of x is 1. It is equal to a. Derivative of sin theta is cos theta into d theta by dx. Carry that dx, 1 into dx, here dx. Now we change the limits. When x is equal to 0, what happen? When x is equal to 0, in this equation put x is equal to, or here, where x is equal to 0, so theta is equal to sin inverse of 0 upon a, that is 0, sin inverse of 0. So 0 is the value for sin of 0. So we get theta as 0. Get it? Now when x is upper limit a, x is equal to a, theta is equal to, now put here theta is equal to sin inverse of a upon a, x is a upon a get cancel 1, so sin inverse of 1, and 1 is the value for sin of 90 degree or pi by 2, in radian it is pi by 2, so we take theta as a pi by 2, theta pi by 2. Now we find this value under root of a square minus x square. So under root of a square minus x square, it is equal to under root of a square minus, here x we put a sin theta, it's a square, so a square sin square theta. So it is equal to under root of, take a square common, a square in the bracket 1 minus sine square theta. So it is equal to, take a square outside the root, we get a under root of this 1 minus sine square theta is cos square theta. Using first fundamental identity, we know sine square theta plus cos square theta is 1, and therefore 1 minus sine square theta is cos square theta. Take the square root of this, square root and square get cancelled. So it is equal to a cos theta. So value of this root is a cos theta. Now given integral I becomes, I is equal to, so required integral I, it is equal to integration from 0 to a. This 0 to a changed to 0 to pi by 2. Lower limit 0, upper limit pi by 2. So here 0 and pi by 2. 1 upon under root of, put the value of x. X plus under root of a square minus x square. X is a sin theta. So a sin theta plus this under root of a square minus x square, we get a cos of theta. So we write here a cos of theta. And this dx is replaced by a cos theta d theta. Now see here a cos theta d theta, here a sin theta plus a cos theta. We take a common, a in the bracket sin theta plus cos theta, and that a and this a get cancelled to each other. And therefore we get integration from 0 to pi by 2. 1 into cos theta, that is cos theta, divided by this sin theta plus cos theta d theta. We call this as equation first, suppose. Now we know that sixth property, which is the sixth property, integration from 0 to a f of x dx, it is equal to integration 0 to a f of, replace this x by a minus x. So it is a minus x dx. Use this property here. So I is equal to integration from 0 to pi by 2 as it is, cos of theta is replaced by pi by 2 minus theta. So it is pi by 2 minus theta, divided by here sine of, here also theta is replaced by pi by 2 minus theta, plus cos of theta also replaced by pi by 2 minus theta, and d theta as it is. So I is equal to integration 0 to pi by 2. Now cos of 90 minus theta on the y-axis. When allied angle is on the y-axis, then we change cos to sin, sin to cos, tan to cot, cot to tan, sec to cosec, cosec to sec. That is when it is pi by 2 minus theta or pi by 2 plus theta, 3 pi by 2 minus theta, 3 pi by 2 plus theta. So here cos of pi by 2 minus theta, this pi by 2 minus theta lies in the first quadrant. So all the trigonometric ratios are positive in the first quadrant. And now cos changed to sin, so sin of theta. Here sin of 90 minus theta, cos of theta, plus here cos of 90 minus theta, sin of theta, d theta. Call this as equation second. Now add first and second. Adding here first and second. So adding first and second, we add left side. Left side is I plus I, that is 2I. So 2I is equal to right side of first equation, integration 0 to pi by 2 cos theta upon sin theta plus cos theta, plus cos theta and d theta, plus right hand side of equation second, that is integration 0 to pi by 2, here sin theta upon this cos theta plus sin theta, d theta. Now here integration 0 to pi by 2, here also 0 to pi by 2, take integration common. So it is equal to integration from 0 to pi by 2 cos theta upon sin theta plus cos theta, and plus here this sin theta upon cos theta plus sin theta, and then write d theta. We take integration 0 to pi by 2 common. Now observe the denominator. Here sin theta plus cos theta, here also sin theta plus cos theta. Denominator is same, so we add the numerators. keeping denominator as it is. So it is equal to integration 0 to pi by 2, denominator sin theta plus cos theta, and numerator here cos theta plus this sin theta d theta. Now numerator and denominator is same, sin theta plus cos theta. Here also sin theta plus cos theta. We know that 3 plus 2 is 2 plus 3. So sin theta plus cos theta and cos theta plus sin theta is same, so we cancel this. And so we get here integration 0 to pi by 2 1 d theta, and integration of 1 we know it is theta, and it is from 0 to pi by 2. On the left hand side 2i, so 2i is equal to here pi by 2, theta is pi by 2 minus theta is 0, means on the right hand side we get pi by 2, carry this 2, so I is equal to, now here it is in multiplication we divide here, so pi divided by this 2 into 2, 4, so final solution is pi by 4, I is equal to pi by 4. So take the screenshot of this problem. Now we see second problem. Integration 0 to pi by 2. Second problem here. Integration 0 to pi by 2 log of tan x dx. Log of tan x dx. So call this as I. So let I is equal to integration from 0 to pi by 2 log of tan x dx. Now since we know that, we know sixth property, integration 0 to a f of x dx is equal to integration 0 to a as it is f of, only we replace x by a minus x, so it is a minus x dx. Use this property, and so we get here integration 0 to pi by 2 log of tan of, in place of x we write pi by 2 minus x, pi by 2 minus x and dx, and just we have seen the formula, sin 90 minus theta, cos 90 minus theta, tan 90 minus theta. So tan 90 minus theta, that is equal to cot theta. So here we get integration 0 to pi by 2 log of tan of 90 minus x, it is cot x dx. Again we know that cot x is 1 upon tan x. So we write here integration 0 to pi by 2 log of cot x we write 1 upon tan x. 1 upon tan x. Now we shift this tan x to numerator using the rule of indices. We know that a 1 upon a to the power m, we write it as a to the power minus m using this. So this required integral I becomes I is equal to integration 0 to pi by 2 as it is log of, now here 1 upon tan x we write tan x to the power minus 1 using this formula. So tan x to the power minus 1 dx. Get it? And now using the property of logarithm, this power become a coefficient. So it is equal to integration 0 to pi by 2 minus 1 into log of tan x dx. Take this minus 1 outside the integral. So this is equal to minus 1 integration 0 to pi by 2, or we only write minus sign now. So minus 1, that is minus integration 0 to pi by 2 log of tan x dx. Get it? Now see right hand side, integration 0 to pi by 2 log of tan x dx. Integration 0 to pi by 2 log of tan x dx, it is nothing but I, our given problem. So we write this as I. Get it? So I is equal to minus this I. Carry this minus I to left side. So I plus I plus I is equal to 0. That is 2I is equal to 0. Carry 2, so we get I is equal to 0. That means the value of this definite integral is 0. This is the solution. Take the screenshot. Now here we will see third problem, integration 0 to 1. Integration 0 to 1 log of 1 upon x minus 1. 1 upon x minus 1 dx. Call this as I. So I is equal to integration 0 to 1 log of 1 upon x minus 1 dx. Firstly take this subtraction. So this is equal to integration 0 to 1 log of 1 minus x into 1, that is x, divided by x dx. Now here use the properties of logarithm, log of a upon b, that is equal to log a minus log b. So here it is equal to integration 0 to 1 log of 1 minus x minus log x dx. And now we use the property, use here property, integration 0 to a f of x dx is equal to integration 0 to a f of, replace this x by a minus x dx. And therefore this required integral becomes I is equal to integration 0 to 1 log of 1 minus x. So log of 1 minus x we replace by 1 minus x. It is 1 minus x minus log of x. So minus log of x is replaced by 1 minus x and dx. So it is equal to integration from 0 to 1 log of 1 minus 1 minus plus x and minus here log of 1 minus x dx. Now here plus 1 and minus 1 get cancelled. So we get integration 0 to 1 log of x minus log of 1 minus x dx. Now here take minus sign common. So integration 0 to 1 we take minus sign common. So this become minus and this become plus. So plus we write firstly, that is log of 1 minus x, and this become minus, so minus log of x dx. Take this minus sign outside the integral, minus integration from 0 to 1 log of here 1 minus x minus log of x dx. Now see, integration 0 to 1 log of 1 minus x minus log of x, integration 0 to 1 log 1 minus x minus log of x dx, this is nothing but I. We call this as equation number first, suppose. So it is equal to I. So left hand side is here I, and this is equal to minus, it is I from equation 1. From equation 1. Carry this minus I. So it become I plus I, that is 2I is equal to 0, and therefore I is equal to 0. So this is the solution. So in this way we have completed here third problem. Now let us start here fourth problem. Now fourth problem, integration 0 to pi by 2. Integration 0 to pi by 2 sin x minus cos x, sin x minus cos x upon 1 plus sin x cos x dx. Call this as I. Solution of this, let I is equal to integration 0 to pi by 2 sin x minus cos x divided by 1 plus sin x cos x dx. So again here we use the property, same property, sixth property use here, integration 0 to a f of x dx is equal to integration 0 to a and replace x by a minus x, that is f of a minus x dx. And therefore I is equal to integration 0 to pi by 2 sin of x is replaced by pi by 2 minus x. So it is pi by 2 minus x minus cos of here x is replaced by pi by 2 minus x divided by 1 plus sine of x replaced by pi by 2 minus x, cos of replace x by pi by 2 minus x dx. Now use the formula sine of 90 minus theta and cos of 90 minus theta. So we get I is equal to integration 0 to pi by 2 as it is, and sine of 90 minus theta, it is cos theta. So theta is here x. So here it is cos x plus minus cos of 90 minus x, it is sin x, divided by this one as it is, plus here sin 90 minus x, that is cos x, here cos 90 minus x, sin x dx. Now in the numerator we take minus sign common. In the numerator take here minus sign common, and therefore I is equal to integration from 0 to pi by 2, we take minus sign common in the bracket. Now this sin x become plus and cos x become minus. So firstly write sin x and then cos x. So here it is sin x and minus cos x divided by, in denominator 1 plus, here cos x into sin x, we may write sin x into cos x. Cos x into sin x is sin x into cos x. So here it is sin x cos x dx. Take this minus sign outside the integral. So I is equal to minus integration from 0 to pi by 2 sin x minus cos x divided by 1 plus sin x into cos x dx. And now observe this problem. This problem is nothing but given I. See here, I is equal to integration 0 to pi by 2 sin x minus cos x upon 1 plus sin x cos x dx. This is I. So we write this as I. So I is equal to minus I. Carry now I plus I, that is 2I. 2I is equal to 0, and therefore I is equal to 0 upon 2, that is 0. This is the solution of the given problem. So we have completed here fourth problem. Now fifth problem, integration 0 to 3. Integration 0 to 3. X square x square 3 minus x to the power 5 by 2, 3 minus x to the power 5 by 2 dx. Now call this as I. So let I is equal to integration 0 to 3 x square 3 minus x to the power 5 by 2 dx. Now use the same sixth property. Use here integration 0 to a f of x dx. It is equal to integration 0 to a f of, replace this x by a minus x. So a minus x dx. And so I is equal to integration 0 to 3. X is replaced by 3 minus x. So 3 minus x bracket square. These two as it is. 3 minus x is replaced by 3 minus x. We write in bracket 3 minus x, and power is 5 by 2 dx. So it is equal to integration 0 to 3. Expand this 3 minus x bracket square. 3 square, that is 9, minus 2 into 3 into x, that is 6x, and plus x square. And here 3, this minus 3 minus minus plus x to the power 5 by 2 dx. Now this minus 3 and plus 3 get cancelled. So here it is integration 0 to 3, 9 minus 6x plus x square to the power x to the power 5 by 2 dx. Now multiply by x to the power 5 by 2 inside the bracket. So we get here integration 0 to 3, 9 into x to the power 5 by 2 minus this 6 as it is, x into x to the power 5 by 2. So x to the power 1 plus 5 by 2. 1 plus 5 by 2, it is 7 by 2. So it is 7 by 2 plus x square into x to the power 5 by 2. So x to the power 2 to the 4, 4 plus 5, that is 9 by 2. 9 by 2 dx. Now we separate the integration. So I is equal to integration 0 to 3 9x to the power 5 by 2 dx, then minus integration 0 to 3 6x to the power 7 by 2 dx, then plus integration 0 to 3 x to the power 9 by 2 dx. Now take integration. Before to take integration, take this constant outside the integral. So I is equal to 9 into integration 0 to 3 x to the power 5 by 2 dx minus this 6 into integration 0 to 3 x to the power 7 by 2 dx plus integration 0 to 3 x to the power 9 by 2 dx. And now take integration using the formula integration x to the power n dx, it is equal to x to the power n plus 1 divided by n plus 1 plus constant of integration. So we get this 9 as it is constant, x to the power 5 by 2 plus 1, 5 by 2 plus 1, it is equal to 5 plus 2 1s are 2 divided by 2, 5 plus 2 7 by 2. So x to the power 7 by 2 and divided by same number that is 7 by 2, and integration from 0 to 3. Now minus 6 x to the power 7 by 2 plus 1, that is 7 plus 2 9 by 2, 9 by 2 divided by 9 by 2, and from 0 to 3 plus x to the power 9 by 2 plus 1, that is 11 by 2 divided by same number 11 by 2 from 0 to 3. 9 by 2 plus 1, that is 9 plus 2 into 1. 9 plus 2, 11 by 2 divided by 11 by 2. So it is equal to this 9 as it is, and we take this 7 by 2 outside this square bracket. We write here this 7 by 2 as a 2 upon 7. So 2 upon 7, so 9 to the 18, so 18 upon 7, 18 upon 7, and in square bracket now x to the power 7 by 2, 0 to 3, so we put upper limit 3, so x to the power, x is 3, so 3 to the power 7 by 2 minus x is now 0, 0 to the power 7 by 2, that is 0, minus here now this 6 into 2, 6 into 2, that is 12 upon 9, 12 upon 9. Now put x as a 3, so 3 to the power 9 by 2 minus x as 0, it is 0, plus here this 11 by 2 we write 2 upon 11, and in bracket now put x as 3, so 3 to the power 11 by 2, now put x as 0, 0 to the power 11 by 2, it is 0. So we get here this 18 upon 7 as it is into 3 to the power 7 by 2. Here minus 3 4s are 12 and 3 3s are 9. 3 4s are 12, 3 3s are 9, and 3 to the power, this 3 to the power 9 by 2, we write 3 to the power 7 by 2 into 3 to the power 1. See here, this 3 to the power 9 by 2. We write this 3 to the power 9 by 2 as 3 to the power 7 by 2 into 3 to the power 1 using the rule of indices. We take addition of these two, 7 by 2 plus 1, 7 by 2 plus 1, that is 9 by 2, plus 2 upon 11 as it is. Here also we write 3 to the power 11 by 2 as 3 to the power 7 by 2 into 3 to the power 2. Base are same, we add the power, 7 by 2 plus 2, that is 7 plus 2 to the 4, 7 plus 4, that is 11 by 2. And now here take 3 to the power 7 by 2 common. So we get here 3 to the power 7 by 2 as a common, and here 18 upon 7 as it is. Here this 3 and 3 get cancelled, so here minus 4, and here plus this 3 to the power 7 by 2 common. Now this 3 square is 9, 9 to the 18, so it is 18 upon 11. So this required integral I becomes I is equal to now here 18 by 7 minus 4 plus 18 by 11, all numerators are in the multiplication of 2, so we take 2 common. So we get 3 to the power 7 by 2 into 2 in bracket. When we take 2 common here, it is 9. So 9 upon 7. 9 upon 7. Here it is minus 2. So minus 2. And here 9 upon 11. Now we have to take the addition of this and LCM of denominator. Here denominator 7, here denominator 1, here denominator 11. So LCM of 7, 1 and 11 is 11 7s are 77. So we have to make the denominator of each as a 77. So we multiply here by 11 to numerator and denominator. So we get here I is equal to 3 to the power 7 by 2 into 2 in bracket. All should have denominator 77. So to make this 77 we multiply by 9. So 11 9s are 99. Here we have merged the denominator 77. So multiply by 77 to 2. 77 into 2. 2 7s are 14 and here 2 7s are 14 and 1 15. So 154. So it is minus 154 plus here to make 77 we have to multiply by 7. So 7 9s are 63. 7 9s are 63. So we get I is equal to 3 to the power 7 by 2 into 2 in the bracket. Now this 99 plus 63. 9 plus 3 12. And 9 plus 6 15 and that 1 that is 162 minus 154 divided by 77. So I is equal to 3 to the power 7 by 2 into 2 in bracket. Now 162 minus 154, 154 plus 6, 160 and plus 2 that is 8. So 8 upon 77. When we take the subtraction of numerator it is 8. And now 8 to the 16. So we get here I is equal to 8 to the 16 upon this 77 into 3 to the power 7 by 2. This is the final solution. Highlight this solution, take the screenshot. So in this way we have completed 5 problems in the question number 3rd of exercise 4.2. So today we stop here. Thank you.